Hi everybody, Patrick here from EscapeRoomElectronics.com, EngineeringShop.com, and PaintballProps.com. This is the assembly video for my current Kickstarter campaign, which is a Dynamo set. And if you don't know what a dynamo is, it's a DC crank that allows for you to generate electricity by turning it. This product can be found at the link below if you're interested in pledging. They come fully assembled with or without dynamos, or in DIY kit with or without dynamos. In any case, what we'll do in this video is we'll put everything together and we'll give it a quick test. So what we got here is the printed circuit board, a 2-pin terminal block, 2 470 ohm resistors, 2 5.6k ohm resistors, 3 0.1 microfarad ceramic capacitors, 4 2-pin headers, 3 1N4001 diodes, 3 100 microfarad electrolytic capacitors, a 3.3 volt Zener diode, and a 4.3 volt Zener diode, and they are in bags separated because they both look physically the same. So that is how you will receive it. So first things first, let's connect our four resistors to the board, and then we'll follow along with our capacitors. The first thing you're going to want to do is separate your capacitors. Make sure that the 470 ohm resistors are together and that the 5.6k ohm resistors are together. The two 470 ohm resistors go in the R1 slot and in the R7 slot right here. They're labeled 470R. Your two 5.6k ohm resistors are the R8 and R2 resistors, labeled 5.6k, 5.6k. So solder those into place. Make sure that there are no shorts. Your resistors have no polarity, so it doesn't matter which way you insert them as long as the correct values are in the correct spots. Next we have our 3 ceramic capacitors. They are labeled 104, but you don't have to separate them because they are the only ceramic capacitors with this kit. And they go in the C4 slot, the C1 slot, and the C7 slot. And again, there's no polarity. These are ceramic capacitors. They are not electrolytic. Both leads are the same size, so solder them in either way. Just make sure that they go in the correct slots. Once we're done this, instead of doing our 100 microfarad electrolytic capacitors, let's solder our diodes. Your 3 1N4001 diodes have a little white stripe on one side. This is very important. You might not be able to see it easily with my camera, but I've got all of the stripes facing up. It's a little tiny white stripe right at the end. The rest of the diode is black. And they're going to go in the D3, 2, and 1 slots right here in a row. And as you can see on the footprint, there's a white stripe on the top side. We want to make sure that when we place these in from a bird's eye view, that the white stripe on the diodes are facing the upper side of the board and not the bottom. We want the black sides of the diodes facing the bottom of the board. So once those are all soldered into place, we will solder in our Zener diodes. We're going to do the Zener diodes in 2 steps. I've removed the 3.3 volt Zener diode from the bag, and I'm going to solder it right here in the 3.3V diode slot. Now, as you'll notice, there is a white stripe on the top, just like with our 1N4001 diodes, along with the 4.3 volt diode, which is down here. Just keep in mind that there's a stripe facing the top of the board. And it might be difficult for you to see, but the diode has it's more of an orange color, and on one side there's a black stripe. So we want the black stripe for both of the diodes to face the top of the board, and the orange side to face the bottom of the board. So the side with the black stripe in this hole, side with the orange stripe in this hole. And then after this we'll solder in our 4.3 volt Zener diode. Just like before, take your 4.3 volt Zener, black stripe facing the top of the board in this hole, and orange side facing the bottom of the board into this hole. Our 4 2-pin headers are placed here, 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 and here. Make sure that the long sides are facing the top of the board and the short ends of the headers face the bottom of the board. This is a very important step. The electrolytic capacitors are all polarized. They've got a long lead positive and a short lead negative, and they go into the C3 slot, C2 slot, and C8 slot. Now, what you'll have to do is look very carefully because there's a plus sign beside the hole that's supposed to be soldered to the long lead. In the case of C3, there's a little plus sign on the lower hole. In the case of C8, there's a plus sign above the top hole from this perspective. And in the case of C2, there's a plus sign above the top hole. So for the case of C3, place your long lead in the bottom hole, short lead in the top. And in the case of both C8 and C2, you want to have your long lead in the top holes and your short leads in the bottoms. Don't reverse this or else your board will not work correctly. and if you misplace C3, you'll likely blow it up if you are cranking on your DC crank. Our last step for the PCB assembly requires that we solder in our 2-pin terminal block. It goes right here. Make sure that the terminals are facing outside and not inside the board. So place it in like so, and solder it in with the leads facing the outside of the board. If you pledge towards a reward tier that includes a Dynamo, the Dynamo will actually come with some extra fun cables and an LED and a little ESD bag. We're not using that for this video, but it's a nice extra that you'll get. So the Dynamo is foldable, and it comes fully greased, so that essentially it extends the life of the Dynamo, because the internal gears need to be oiled, but the outside you can just give it a wipe down; it'll be squeaky clean. Now we're going to connect this connector to the Dynamo. For those of you getting DIY kits, for those of you who have assemblies coming to you, I will solder that myself. And what we have here is on the back there's 2 solder tabs. One has a little red dot above it. What we're going to do is we're going to solder the red wire to this pad here, and the black wire to this pad here, and then we're going to connect to the main board. Now with the wire soldered, if you want, you can add a little bit of hot glue just to keep them from moving around too much, and we've got our connector. Now on the main board, there is on the lower left there is a 2-pin header. I'll give you a zoom in of it in just a second, but there are 2 pins labeled NEG for negative on the top and POS on the bottom for positive, and we're going to connect the Dynamo to that pin, or those pins rather. Just like that. Red to pos, black to neg. Now on the top of the board we've got a terminal block on the left and a 2-pin header on the right. Now if you want to generate electricity, that's halfway rectified, anywhere between 2 volts and roughly 14 volts DC to power, say, an LED bank or what have you. You'd connect either here or here. In the Kickstarter video you'll notice that I connected an LED bank here. These are interconnected. We've got the terminal block, which allows for you to connect wires to and screw them into place. There's ground, GND, and DC plus. So that is DC plus is where we would see the power coming from the Dynamo, and ground would be our ground connection. And the 2-pin header right here has GND and DC plus. Again, they are connected. DC plus here is connected to DC plus here, and ground GND is connected to GND here. It just means that you have the option of using either the terminal block or the 2-pin header. Here are our output headers. We've got 2 headers. On the upper side we've got our Raspberry Pi header, and on the lower side we've got our Arduino header, also compatible with microchip products. We've got GD for ground and 5V I/O, which means we can connect it to a 5V compatible I/O pin. We'll be using that for Arduino. And on the upper side we've got another GD terminal, which is again ground, and 3V I/O, which means we have our 3V compatible pin for Raspberry Pi. So when you charge the system, when you charge the Dynamo, we'll see just close to, in the case of the 5V I/O compatible pin, we'll see between 4 and 4.3 volts. And on the 3V line, we'll see between 2.7 and 3.3 volts, depending on how hard we turn the crank. Now, in the case of the included software sample for Arduino Uno that comes with this campaign, what we would do is we would connect the GD terminal on the lower header to a ground terminal, one of the GND terminals on the Arduino Uno, and the second pin, the 5V I/O line, to GPIO number 8. And really that's all you need to do to work with in the included software that's actually seen demonstrated in the Kickstarter video introduction. And so that's all you need to do. You can also include a relay, and the instructions on how to do that are actually commented in the code that's included with this campaign. But just to give you an idea, what I'm going to do is I'm going to connect a multimeter to the 5V I/O line, just to show you what happens when you turn the crank. So I've got my multimeter connected. What I'll do is I'll just start turning slowly. 3.6, 3.7 is still compatible with the Arduino input, and I'll start cranking faster. And we got 4 volts. Now I can do the same thing with the 3 volt I/O line, but you get the picture. We'll see between 2.7 and 3.3 volts. The Zener diodes act to limit the voltage going through those lines, so we can safely use this dynamo with our sensitive microcontrollers. Now if I connect to the output terminal that gives power to, say, power an LED bank or whatnot, we'll see a very different range of voltage. Now we've got some residual capacitance on the line because there's a decoupling capacitor and a 100 microfarad electrolytic capacitor on the line. So what I'm going to do is I'm just going to charge. We see 12 volts. Now if I stop charging, here's an interesting thing. What you'll notice is there's still 12 volts on the line, and it's slowly dissipating, and that's because the capacitor, because the circuit is unloaded, it's not powering anything. So this is power that's left on the capacitor. So as soon as I short these two pins together, that disappears. And of course we still got some residuals, but as long as I short it, I have 0 volts. So that is the line that we would use to power our LED banks, or our small motors, or even perhaps a loud siren. So that's all you really need to know. This is a very, very, very simple campaign. It's almost completed. If you have any interest, check out the campaign. Easily my most simple and smallest campaign, and I actually have all of the components in stock to ship rewards as soon as the campaign is over. Well, more or less, I'll have to send out the surveys, and I'll have to wait to make sure that all payments do not fault. But aside from that, the rewards in DIY form and in fully assembled form are ready to go. So if you haven't already, check out the campaign below. Thanks for watching, everyone.